Hey everybody, hello. We're going to do 11.6 Pre-Algebra Math today, Part 1. And our lesson today is about permutations. We got a 40-point classwork sheet today. And we have a 0-point notebook taking. Today's spell work teachers, multiple choice and then a survey question. Describe the sampling method, students. See, 800 survey of random, blah, 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 blah. Predict the total number of students who in the school who enjoy swimming. So we have that situation. Give your students 5-6 minutes for this, teachers. Okay, welcome back. Our solutions up here. We got a 48 out of an 80 situation. So find 60% of the total number of students in the school. So 60%, this is of our sample here. 60% of A be 480, so your prediction would be 480 students. For number 1, H, and then number 2, into 2 groups, and chooses members from each group. The sample is a stratified, this would be a stratified sample. Hey everybody, let's get into our classwork, page 1. You use the counting principle. You'll use permutations to count possibilities. Number of permutations equals choices for first letter times choices for second letter times choices for third letter. So here is an example here of a situation for a number of permutations of ABC. So we have choices of first letter, choices of second letter, choices of third letter, choices for again for further choices here, and then we come up with these permutations here of ABC. ACB, BAC, BCA, CAB, CBA. So how do we figure that out mathematically? Is an arrangement, a permutation is an arrangement of objects in which order is important. For example, the 6 permutations of ABC are shown. So these are permutations here of ABC. And then for this example here, you can use the counting principle to count permutations. Each time you choose a letter to make a permutation of the letters ABC, the number of remaining letters that can be chosen decreases by 1. So when our first choice is 3, our second choice is 2, and then our third choice is only 1. In that situation, you have 6 total choices for a situation with 3 individual members of your permutation. The expression 3 to 1 can be written as 3 factorial, which is read as 3 factorial. For any positive integer n, the product of the integers from 1 to n is called n factorial and is written like this, n with like a exclamation point. So for example, n factorial equals n times n minus 1 times n minus 2, blah, 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 times 1. So it ends up with 1. And the value of 0 factorial is defined to be 1. So first example here, counting permutations. You have 4 posters to hang in your room. You want to put 1 poster on each wall. How many ways can you arrange the posters? So you have 4 choices for first wall, 3 for second, 2 for third, and 1 for the fourth. So the number of ways you can arrange the posters is 4 factorial. And this will be the mathematical representation of it. There's 24 different possibilities for that. So that would be the way that you would figure this situation here. Into our first guided practice, evaluate this factorial. Students, this is yours here. Pay attention so you can do your independent. 6 factorial will be 720. So that's how 6 times 5, 4, 3, 2, 1. Okay, so suppose in example 1 you had 7 posters and wanted to choose 1 poster for each wall as in example 1. You can use the counting principle to count the number of possible arrangements of posters. So number of permutations equals choices first, second, third, and fourth wall. So 7, 6, 5, and 4 will be the way that you would do that. You would have the first 4 choices here, and then that would come out to be 840 ways of doing this up here. 7 posters and 1 for each wall. This situation is an example of finding a number of permutations of 7 objects taken 4 at a time. Notice that 7, 6, 5, 4 can be written like this here. 7, 6, 5, 4, and then these cancel here. So it'd be 7 factorial over 3 factorial. This example suggests the following rule of permutations. NPR, where NPR equals n factorial over n minus r factorial. And then for plugging in numbers here, 5, 3, you'd have 5 factorial over 2 factorial, 5 minus 3, and it would be 60. So that would be the way to do it here. If you had 5 posters and you had 3 walls, and this would be the amount of combinations you could. So example 2, judges at a science fair awarding prizes for the first, second, third place finishers. Science fair has 10 contestants. How many different ways can the first, second, and third prizes be awarded? So the number of ways it could be awarded would be represented by 10p3. 10p3 is equal to 10 factorial over 10 minus 3 factorial. It would be 10 factorial over 7 factorial. This would be the permutation here. And then what would that come out to be? So you cancel all this stuff out here, because it would be 10 minus 3 would be 7 factorial. So all these cancel. Then you're left with this number here, which is 720 different ways of awarding the prizes for the science fair. So into a situation here, find a number of permutations here. Students, that's yours. 7p2, so it would be 70 factorial over 70 minus 2. And then you just start here at 68, so you have 70 times 69 factorial. That would equal 4830 permutations there of that situation. That is 11.6, part 1. Part 2, part 3 available at this email, as well as worksheets and other stuff for the whole pre-algebra course. Thank you.